Hello, hello, hello. Welcome to another session of our live Azure study series. I hope you guys had a wonderful weekend and a very pleasant Monday. Say, David, so how was your Monday and weekend?
Yeah, going well. It's a strange thing though. Okay, yeah, so no, sorry, apologies. So I was just checking out a few things. I was checking out Bitcoin, sorry.
Oh,
No,
okay.
I'm only kidding. No, no, not checking
Yes,
out Bitcoin. I was
yeah, it's an
making sure
interesting
to
one.
I was making sure to be I was checking to see that we're live. It's just
Oh,
this
okay.
this Elon Musk guy that keeps causing all kinds of issues.
Yeah, seems that he's in control of this crypto. Keep crashing it every now and then.
It's so strange. I'm not even sure. Is that something that's even legal? Like, is it? Well, if it doesn't have like any personal asset, I think that's legal, right? I'm not sure.
Well, I mean, the way I look at it, you are free to talk about things, I guess.
Yeah, but if it's like if you're manipulating like the market
Yeah,
when you
he is
also
though.
have when you have the investment, then that
Yeah,
becomes an issue. But maybe it doesn't have like anything that's bought, so maybe that's why.
yeah.
Okay, yeah.
So well, I mean, based on what you're talking about, I bet your investment has been affected. I'm just joking. No, but yeah. So today, what do you have for us today, Sir David?
So today will be about now network traffic management. So in the past few weeks, we've been talking about networking. So we started by talking about like an overview of networking. We talked about DNS. Then we talked about inter-site connectivity the last time. But this time around, we take it further. So this will be the last section on networking for the Administrator Live Study series. So this time around, we're talking about network traffic management. And there are three main things that we're going to look to cover. Let me go to bring up my screen. So we're going to be looking at load balancing options, and we're going to be looking at three main services in Azure. A service called the Azure Load Balancer, another service called the Application Gateway, and finally, a service called Traffic Manager. So those are the three services that we're going to be looking at today.
Okay, that sounds great. So I believe all of these are for managing. So that means there are many ways to manage traffic on Azure network. I mean, Azure environment based on
Yeah,
yeah.
Yeah, because here's the problem. So the problem that this is trying to solve, Sarkozy. So here's the problem. So, it's for many enterprises, right? You're not going to have like a business critical application and have it running on a single instance, right? So it does not matter which service you're using in Azure, whether you're using a virtual machine, whether you're using Azure App Services, Azure App Service. If you have a business critical application, you probably want some type of high availability and redundancy configured with that. Now,
All right.
if you're doing that, then you have to have a way to send traffic to the endpoints that you want traffic to go to. So that's the reason for the title, network traffic management. We want to manage
Got it.
traffic. How traffic will be delivered to our endpoints in Azure if we have them split across multiple instances. So that's the study for today. So that's what we're going to study.
All right, that's exciting. So since we have three services, is these service can they work together or I mean you can only use one at a time?
Yeah, they can work together. They can definitely work together. So, but it's more like understanding the use cases. So I'll show you, for example. So there is this nice document from Microsoft called the Azure Architecture Center that has just different architecture that people have other Azure customers have implemented in the past, for example, right? So if you go have a look at the Azure Architecture Center and you begin to look at some of the different, services and some of the different patterns that they've listed in the past. If I scroll down on the left hand side and let's say I go to under something like the web pattern, and you go to like see maybe sample architecture. So for example, e-commerce front end. What you notice is that depending on the use case, they have different services. So for example, here you're looking at one of the services that we're talking about, Traffic Manager. So if I open that image in a new tab, so you can see that has Traffic Manager right there. If I go to another architecture, and let's say I go to an architecture that's talking about virtual machines. So let's go look for an architecture that's talking about VMs. being used for that case. So that's scalable web app, that's app monitoring. Let's go to on the compute and let's expand this. Let's go to on the architecture. Let's go to on the something like let's see. Da-da-da. So there are different services, right? You go to like under high availability and you go to like multi-region web application. You see that different services show up depending on the
Okay.
use case, right? So that's what you see. And that's what we're going to try to help to try to study and understand today. When do I use which service? What's the use case? So that's what we're going to look to.
Right.
So the first thing that I'm going to start with is let's start with load balancers first of all. So let's go to the next option. So load balancer is very basic, right? So a lot of us know load balancers. It's a way to again split traffic across multiple instances of an application. But in Azure, there are two different types of load balancers that we can implement. So we have something called the basic SKU, and we have something called the standard SKU, and they have different use cases. So let's start with the basic SKU first of all. So with the basic SKU, it's not zone redundant. So now, Kofi, I'm gonna just ask a question regarding
Yeah.
what we discussed in the past. So do you remember like what we mentioned that availability zones are? So what availability zones are in Azure? So we mentioned like in the beginning, we mentioned the concept of availability zones in a region and what they are.
Yeah, that's right. So it's more like the various data center in a specific region. Yeah.
Exactly. So that's absolutely correct, Kofi. And that's the point with this basic option of the load balancer. It's not zone redundant, which means you can only use it to distribute traffic within a single data center. So let's say we take UK South, for example, where there are three availability zones: zone 1, zone 2, zone 3. If your instances of your application are in a single um, data center, you can use basic to distribute traffic to them. So you have one instance in this availability zone 1. Second instance is also in availability zone 1. You have the basic load balancer. You can use this to distribute traffic to them, right? So we
Yeah.
just call this web application 1 and web application 2. However, if you have a situation where you have maybe web application 3 over here, you cannot use the basic load balancer to distribute traffic to this because it's not zone redundant. It does not understand the concept of this is zone 1 and this is zone 2. It doesn't do that. So that's that one. So, but it has its own advantage. It's free.
Oh,
So,
I see.
so, so you don't pay for anything.
So
So
that means it's not just that. That probably might not be the only disadvantage. Then there might be multiple.
so that's the main one. It's not
That's the
zone
main one. All
redundant.
right.
Yeah, it's the main one that is not zone redundant. Apart from that, it does is work well. So if
So
I go, yeah, sorry, carry on, sir.
no, you go for it.
Yeah, so if I go, for example, to the Azure portal very quickly, and I go to my Azure environment and I go to create a resource. And when I go to create a resource, if I specify I want to create a load balancer, because the reason why I need a load balancer is I have multiple instances of my application. So here's where you have to be a bit careful also. So I'm typing load balancer in here and nothing is showing up, right? So it's like all
Yeah.
these options that are showing up are not Microsoft load balancers. So just be a bit
Okay. So
careful
these
there.
are all third party.
Yeah, all
Load
third
balancers.
party load balancer. So what I'll do is I'll just go search for load balancer over here. I'll go to load balancers option. And here I can then go to select, I can go to select new load balancer. And if I go over here, you see I put it in a resource group like we always do. I give it a name. I'll say basic LB1. And if I go over here, you see the skill, I can select standard or basic. If I select basic, you can see that the option where I can specify tier, region, or global grays out. If I specify standard, I can select. If I specify basic, it's like, no, you only got
Oh,
one
I see.
option. You only in one availability zone. right? So that's the thing with basic. So I can only use it for one availability zone. So let's go very quickly because it's free. It has the advantage and stuff. So then we have the standard. The standard, on the other hand, as you can imagine, it is zone redundant.
Yeah.
Yeah. And what that means is that if I go to erase this from the screen, so if I go to, I can have my load balancer distribute load across to multiple instances across different availability zones in the same region. So this is my UK South region. I have my basic load balancers. I have my instances split across multiple availability zones in Azure. Standard load balancer can handle that.
What about Geo?
Very good question, Sir Coffee. So here's the thing: is that um, standard load balancer in the past can only distribute load or traffic within a single region. So it can distribute traffic across availability zones, but within the same region.
Same region. All right.
So, however, I saw this like maybe about 2 weeks ago, and I've not really found that much of documentation on it. If I go to change this to standard, Microsoft added this new option for global, right?
Yeah.
So, and if you look at that definition, it says a cross-region global load balancer can only be deployed to a home region, blah blah blah. So this is one that we really need to go because as at maybe like a few weeks ago, there is no option to do cross-region load balancer. A load balancer is limited to a single region, right? However, there is this new option for global, which I
All right.
assume that's what it's doing.
Got it.
Yeah. So those are the options that we have. So let's see, like basic, sorry, standard. Does it have any other advantage apart from its zone redundant? Well, I'm not sure if you consider this an advantage, but for my great man that I'm speaking with, you may consider this an advantage. Let me clear the screen. So because you do get to pay for it. So I know Sir Kofi, the generous man, money flowing everywhere. so so you have to, and the way that you pay for it is you pay based on the number of rules. So the number
Right.
of load balancing rules that you've configured and the amount of data that it processes. So that's what you pay for. So let's see. So we've mentioned that we have two load balancer types, basic and standard. So let's see some other information. So when we're creating our load balancers, they could also be internal or external. In other words, internal or public, right? So that's very important. And the significance of this is actually very simple. If you have an internal load balancer, it has a public IP. Sorry, it has a private IP address.
That's
If
right.
you have a public load balancer or an external load balancer, it has a public IP address. That's essentially what it means. Now, let me show you that in a real architecture, and so we can see. So let's go to have a look at something like this, some architecture in Azure. So let's go to multi-region load balancing. And here is a sample architecture for us to consider, Sir Kofi. So if you have a look at this architecture right here, so you see that this architecture has a load balancer that has a public IP address.
Yeah.
And that load balancer that has a public IP address is distributing load. So by the way, this is not like a real load balancer, this application gateway, but let's just assume it's a load balancer. But it has a public IP address and it's receiving traffic from the internet and it's distributing that traffic to the web tier, to the front end. Now you notice that the web tier has multiple application instances in the middle tier to interact with, but you can see that this one doesn't need to have a public IP address. So this would be an example of an internal load balancer. It does not have a public IP address. It has a private IP address, but that it can use to distribute load internally. So this would be useful if you have like an internal web application, for example, Kofi.
Got it. Right.
Yeah. So that's sort of like the way that works. So we can have that internal or external. So that's
So based on that graphic you showed us, you can have multiple layers of load balances. So for example, in a mid tier, there can be another load balancer behind that data tier as well.
Exactly. So it
And
depends
now we
on
have an
essentially.
internal address, internal
Exactly.
IP address, right?
Yes, sir. So, for example, if you have a look at this one, so this would be, you can see an example of this one also, which is similar to what you're talking about. So, this has like a load balancer in front that has a public IP address receiving traffic from the internet. Now, you can see what you were asking me where they're being used together. Now, you have Traffic Manager receiving the traffic initially, then sending it to a load balancer within a region, right? So, this would be something like the standard load balancer if this is across multiple zones, and then you have the web tier, and then an internal load balancer across different instances, and then behind that another load balancer that's distributing to the data tier. So now you have multiple levels of load balancing. The goal here is about making sure that traffic gets to the endpoint that traffic needs to get to. So that's the goal.
Got it.
Yeah. Okay. So let's see very quickly some other things that we want to cover in this study. So our load balancers can be public or private. A public load balancer means that it has a public IP address, and that is what we mean. So now this load balancer over here has a public IP address reachable from the internet. So that's a public load balancer. Private means it doesn't have a public IP address. Like this one would be a private one. So it does not have a public IP address to receive traffic.
Right.
Okay. So the other question then is, so now we understand load balancer, basic, standard, internal, or external. So what about the endpoint that they can distribute traffic to? What endpoint can they distribute traffic to? That is what is referred to as the backend pool, right? That is what defines the endpoint that traffic can be distributed to.
And is there any limit to how many backend endpoints you can have? Or
Very,
is,
very good question, Sir Kofi. So to answer that question, I don't know that off the top of my head, but we have Azure subscription limits and quotas. This is a document from Microsoft that talks about the different limits of different services in Azure. So what we need to do is we need to search for load balancer, and let's look for under the let's see, load balancer where you, that's Kubernetes service. Yeah, here we go. Load balancer limit. So let's see. So
well,
backend pool size. So you can see,
1,000?
yeah, standard load balancer has a backend pool size of 1,000 IP configuration, single
And,
virtual network.
and I believe some companies more likely will meet that and will probably demand more.
Probably, probably, especially like sacrifice type of organizations. You have a lot of employees. Bitcoin is doing well, gold is doing amazing.
You
You
have to
know,
scale up.
exactly. So you need a lot of those resources to be able to help to do that. So yeah, so that's essentially the limit. So backend pool size, actually, if you look at it, so it's very so basic. It's like 300 IP configurations. And then single availability set. Standard can go up to 1,000, IP configurations and stuff. So let's see some other information about it. So these are the backend instances that traffic will be distributed to. So what options can we select? So for example, what we're talking about is we have a front end, which is maybe it may be an IP address or something that's taking the internal traffic and passing that to our load balancer. Our load balancer has the backend, and the backend options that we can have a virtual machine, we can have a virtual machine scale set, we can have an availability set. So those are the options that we can have. So it's essentially virtual machines, virtual machine scale set, or availability set. So we'll talk about this when we get to the compute sections. When we start talking about compute, we'll talk about virtual machine scale sets and availability sets when we get to that study section. So let's see some other information. So basic, we can have up to 100. So actually, we know that that is no longer accurate because we just checked the current value and it says 300. So
300.
we can have up to 300 IP configurations.
So this is one of the things about Azure, whereby things constantly, keep updating.
Yeah, and
Yeah.
that's one thing is that it's so tough. It's so tough to keep up to date with that. I'm not sure. Do
Yeah.
you have like a tip for the people, Sir Kofi? Any tip for how people can stay up to date with all this? Like for example, there's next week is a big conference. It's the Microsoft Build conference.
Yeah.
So there's a lot of announcements that will happen next week again. Like, how any
Yes.
recommendations that you have for the people on how they keep up to
Well,
date?
I think the key is that constantly you should be engaged with. I mean, if you are someone who would like to learn about Azure or any cloud service, the specific sort of like a cloud you're interested in, you should be constantly probably checking their website, going to their conferences, and those sort of things. So that's how you can actually stay up to date. Because
Yeah.
once they make the changes, more likely they will update it in their documentation, just like we just found out. So constantly keeping yourself involved with whatever they're doing is something that can help you to know what is current.
Yeah, yeah, I agree with you completely. And man, do I miss those conferences? Do you remember the conference, the last conference that we went for together,
Yeah,
Sarkofi?
in
Was
Birmingham.
in
Yeah,
was it Birmingham? Yeah, it was in Birmingham. I don't think you followed us to myself and Sataiwo and others who
go
went
to
to the one in
London.
London. Yeah,
Uh,
but I think you were not able to make that one. The one.
no.
How was your experience? What was your experience like attending that conference? Because sometimes I think sometimes people we don't see the importance of some of these things till we experience
Yeah,
it.
exactly. I mean, that was the first conference that I went to, and you can see that everyone is there to learn, and having that sort of small pocket of learning sort of like centers, you can easily go to the ones that you really enjoy and can meet people in the industry, which I mean, it go a long way. You realize that the people you meet are the same people probably you might meet somewhere in your profession. So these things are very, very good. If you have the opportunity, I know now it's the current climate with the COVID. It's hard for people to really organize this sort of conference. But if there is a conference and you have the opportunity to go, you realize that there is another avenue that you can learn a lot. So yeah,
Yeah, completely agree. Completely agree with that, sir. So here we go. So we have the front end, we have the back end, and we have these options. So let's go ahead and let's go do some interesting stuff. So Sakofi, what I'm going to do is I'm going to go demo time. So enough
sure.
of talking. Let's go do some demo. So what I have here, Sakofi, is I have some virtual machines, and the virtual machines are hosting web servers. So they're hosting web servers that are public. So let me show you very quickly what I have. If I go on the virtual machines. So let's go look for virtual machines. What I have is that in UK South region of Azure, I have a virtual machine that's hosting a web server, and in West Europe, I have two virtual machines. So in the same region. So what I'm first of all going to do is I'll go ahead and create two load balancers. So I'll create one, which would be which would be just basic. So basic, I'll put this in West Europe, and let's put this basic West Europe. So let's go to public. So it's going to have a public IP address. So I'll make this basic, and public IP address name. I'll just call this the name and then public IP address. So let's do that very, very quickly. Let's do that. Pip IP address dynamic assignment. So I'll just leave it dynamic IP review and create, and boom. So that should create that. So that should take less than I can't say that it would take less than 30 seconds, but the one I'm about to create now, Sakofi, will
Yeah.
actually take less than 30 seconds to create. And actually, if you read Microsoft documents, you see those kind of information in the document where they say it will take about less than 30 seconds to create.
Is there a reason to that? I
Yeah,
mean,
what do you think? What do you think? Like, look at it. It's created now, right?
yeah.
What do you think why it's like it's like, oh, it's going to take less than 30 seconds to create? So actually, it's one of the advantages of the basic over the standard is that it even takes lesser to create.
Well, you're paying money, so what?
I like that answer.
So
That's an
they,
amazing
they, they have
answer.
to create some ways to distinguish the two, make it very clear that if you're taking the basic, it will take some time.
Why does it live? Why do they have to make it like so? So always show that it's also always show also like if you ever go for like the flight and it's like first class come in first,
Exactly.
and then it's like the rest of you people that are still struggling with all this stuff. Go ahead and pack yourself and So you see an example of what I'm talking about,
That's
Sakofi. So
right.
when
Yeah.
I'm creating standard, you can see that I can select, zone redundancy and all that stuff.
Yeah.
So I can select that. But for basic, that option doesn't exist, right? I can select zone redundant or all that stuff. But for standard, I can select that. So I'm not going to be just IPv4 address that I'm going to create. So I'm just going to go ahead and create that. So yeah, just to answer that question very quickly, Sakofi. So the reason is because they're not actually creating anything in the backend.
Right.
So what they're doing is they have a distributed set of nodes in the backend. They are just adding our configuration to that distributed set of nodes. Because again, remember, software. Can you see that? It just took a few seconds
That's
because
right.
that is software-defined networking. It's not creating anything. The nodes are there. It's just like here's a new configuration. Slap it on it. There we go.
Wow.
Start to receive traffic.
Yeah, that's impressive.
So now that I have this, it has a public IP address. At the moment, it's not distributing traffic to anything. So to do that, I'll go to configure my backend pool. So let's go do that. So for my backend pool, I'll go ahead and click on add, and I'll specify the network that this is going to serve. So I put that network. So the backend pool, you can see I can specify a network interface or an IP address. So I can specify
Right.
either. In this case, I'll just leave it as network interface, and let's go to let's see. Oh, okay.
So that probably that resource or VM that's the virtual network that doesn't have any um
There's
in there.
I think that there should be a way around that. So that's a very, very good one, Sakofi, because what's going on here is I do have virtual machine resources. However, so I sort of like cost this for myself because what I've done is when I created this, I
Yeah.
have public IP addresses associated with them.
Right.
Now, the public IP address that I've associated, Sakofi, it's let's see the SKU of my public IP address. So let's go to under properties, and you can see it's the basic SKU. So essentially, what is going on here, Sakofi, is that I have my load balancer resource that's zone redundant, right? So I
Yeah.
specify zone redundant, and that's the reason why it's a standard SKU. However, I have virtual machine resources that are using the basic IP address SKU, which means limited to a zone. So he's like,
Got
no,
it.
it's got to be standard all across.
All across.
If
Yeah.
I'm going to be having standard that, then my the public IP addresses of my virtual machines also have to be standard. So that's what it's complaining about. It said you got basic SKU and you're selecting a standard load balancer. Sorry, go change the go change the IP addresses
Got it.
to standard first. But anyways, it's good that I created the basic one also. So Sakofi will actually get to use the basic one. We use it for free. So let's go select that basic load balancer. So it operates in a similar way. I go to my backend pool and I go to add my backend pool. So I'll just call this web pool for my web, and I specify West Europe associated to virtual machines, and I can go ahead and add my resources.
All
So
right.
I have the first one, the second one, I had both of them. And there you go, Sakofi. I go ahead and click add. And that's it. So now I've added the backend pool, but that's not the end, right? So I've added the backend pool. The next thing that I need to consider, Sakofi, is the load balancer needs to be able to assess and check the backend. Are you available? Are you good to serve traffic? Are you okay? It's going to be able to check the health. So that is
Oh, yeah.
referred to as the health probe. So when talking about the health probe, in this case, let's see how that works. So health probe is a way for the load balancer to evaluate the backend and see are they okay. So in other words, it does not want to serve traffic to the backend if it's not available to receive traffic, right? That's not a good user experience, right? A user is being directed to a backend instance that's not available. So in order to monitor the health, we have to tell the load balancer to say, check my application in the backend on port
Yeah.
80, check it every 5 seconds. If it does not respond to you after 2 tries, I want you to remove it. So we can either do HTTP health probe or TCP health probe. So if we do, so essentially we can specify the on LD threshold. We can say how many times should it try to contact the backend before it goes, you know what, you're not responding, I won't send any traffic to you. So that's
Okay.
that.
So when it checks and realizes that it's not responding, after
Yeah.
that, does it continuously try to send some probe to see whether it comes back up?
Yes. So the probe will always be continuous, but it
Uh,
just goes, I'm not sending traffic to you
got it.
until you start responding again on that port. So the probe will always be continuous, whether it's live or not live. And the
Got
IP address that is going to be sending the probe from is the IP address that we saw last week, that special IP address of
it. Yeah.
168. Yes. So that's the IP address that is going to be sent. So when you're looking at your virtual machines and you're doing like a packet capture, that's the IP address that you see.
Got it.
So you can go. So the default is every 15 seconds is going to check, but you can reduce that to 5. And it supports two protocol, HTTP, which if you use HTTP, it's going to expect to get a 200 OK response, an HTTP 200 response back. So it's going to make an HTTP call to the backend on the ports that you specified. It's going to expect to get a 200 OK response back.
What about HTTPS?
So, very good question. So, no, not HTTPS at the moment. So, it's just HTTP. So, it's HTTP and TCP that it's going to use. So, because it doesn't have capability to do like TLS and shake.
Got
So,
it.
it doesn't do that yet. So, we talk about another one in a few minutes that can do that, which is application gateway. So, TCP will just check for, successful TCP three-way handshake, right? So that's what it's doing. It's like, ARC, SYNAC. So essentially it's like SYNAC,
Yeah.
ARC, boom, we're good. You're good. So that's essentially what that's doing. So let me go quickly configure the ELD probe for my backend instance. So I've added this, I believe. So let's go ahead and add that backend probe. And then I'll go configure my held probe to check on port 80. So I've got my pool. Oh, actually, yeah, so they are part of the same pool. Awesome. So let's go to the held probe. And for the held probe, I'm going to go add held probe. I'll just call this web pool probe. And I'm just going to use TCP on port 80. I can only go as low as 5 seconds. If I try to go lower than 5, it's going to complain and say no, minimum is 5 seconds. So I can only go 5 seconds. On LD threshold, how many times shall I send the probe before I go? It's not LD. I'm going to say do 2 twice. So what that means is that there'll be like a 10 seconds period if there were to be a downtime before this instance is removed. So that's 10 seconds. So it's going to send first 5 seconds, second one in 5 seconds, not responding, you're out for now. And you'll keep checking. So I'll leave that as a default and I'll go ahead and just click add. And that's going to go ahead and add that. So now that we have that, what does that complain about? Okay, yeah, you know what? Let's just go ahead and do that again. Sometimes, like, it gets these temporary errors in the cloud. We have to be prepared for them. Okay, so why is he not responding? What does he not like? Let's see if we can get any other information. So it says they belong to the same availability. Okay. Um, let's see. Da-da-da. So basic LB1 belong to the same availability set. Oh, I think it's complaining about my configuration against the coffee. I really need to set things up correctly. So let's go back to under my load balancer. And I think it's complaining about the
Backend
way,
pool.
yeah, my backend pool and the way that I've configured things. So my virtual machines, I think, I've not added them to that set. So, but that should be fine in terms of the probe. Let's go ahead and try that again, Takofi. Let's do that one more time. So let's refresh that. I think it's going to probably just carry on complaining. But I've got my 2 network interfaces there. And let's try that one more time. So let's go to add. Maybe let me use this HTTP and let's go web pool probe. I think that is going to be the same result because HTTP or TCP is the same thing that it's doing. It's just doing the probe. So if that doesn't work, I'll probably just move on. But people get the point. Yeah. So my virtual machines, the way that I've configured them is what it's complaining about here. So, I'm not going to spend a lot of time trying to sort them out and everything. We can always show that next time. So, anyways, let's move on.
And also,
So,
we have it in the lab as well.
oh,
So
awesome.
later on,
Awesome.
yeah.
Thanks very much for bringing that up, Sakofi. So, we have that in the lab also. Yeah. So we have our session persistence, which is the other thing that we can do. So session persistence means this. So in some cases, Kofi, if my application is designed in such a way that I'm storing the state information on the instances themselves, now that's not a good practice for cloud applications, right? That's a poor practice. What you want to do with cloud native applications is you want to decouple the state from the instances, right? So that if this instance goes down, it doesn't take the state information with it, right?
Okay.
So that's the best thing that we want to do. But let's say you're still working with legacy application that stores state locally. So a user that's connected from this client and connecting through the load balancer has been sent to this instance, and this instance is keeping their state locally. We want to ensure that any other traffic that's coming from that user keeps being sent to that same instance, because this is where the state is. If they get sent to this instance, then this instance goes, I have no idea what you're talking to me about, right? That information doesn't compute with me. So that is the case when we need session persistence, right? And we can configure that. So what are the options that we have to configure session persistence? We can use client IP. We can say anything with the same client IP always gets sent to the same backend. So if your IP is 1.1.1.1, no matter which port you're communicating from or to, you always go to the same backend once that backend is selected. Client IP and protocol means I can say, okay, if I get a session for 1.1.1.1 and the source port is port 380 or 3800, and say the combination of this IP address and protocol, not port number in this case. So apologies, let me wipe the screen. So the combination of IP address and protocol, in other words, if it's TCP and it's coming from 1.1.1.1, you always get sent to the backend. Now, if 1.1.1.1 changes and starts to use UDP, that could be sent to another backend. But as long as it's using the same protocol coming from the same client IP, you're always going to the same backend. So that is what that's talking about. So those are the two options that we have when we are configuring that. So sad thing is that I'm not able to show this, but here's what I can do, Sakofi, because I just got an idea. What I could do is that what it's complaining about, I can still go ahead and show you load balancing without multiple backend. So what I'll do is I'll go remove one of the backends, just keep one of them. What does it not like? That's strange. That's absolutely strange. No, that's really, really strange. It's like just get rid of this in the pool, and it doesn't like to get rid of it. Have I run out of credit in my subscription? Is that what's going on? No, I've not run out of credit. So sometimes, I'm guessing something else that's going on. So what I was going to show you was, so if I go to, because I don't have a health probe, but if I go to under load balancing rules, I will show you where that option exists. So, I select my front end IP address for the load balancer. And when I'm configuring this, I go ahead and select the backend pool to send traffic to. I select the health probe to use. And then for the session persistence, I go ahead and select either client IP or client IP and protocol. So again, depending on which one I want. So client IP is more sticky. It's what you call this more sticky. Because essentially, no matter which protocol that IP is using, you're always going to the same backend. So it's more sticky. So client IP and protocol is less sticky, because if the protocol changes, the backend could change. So that's what we're talking about there. So hopefully all of that makes sense. So that is what we're talking about in this particular case. The other advantage to quickly mention before we start talking about application gateways, Kofi, is that we can have multiple front-end IP addresses for load balancers in Azure. So so which is great, because that makes it much more easier. I can have multiple, front-end IP addresses and then going to, multiple backend instances. So that's possible. So that's where we'll stop for this one. So the next one that we're going to do is that we're going to quickly cover application gateway. and then we'll talk about Traffic Manager, and then we'll stop for today. So we only have about 20 more minutes. So application gateway, what is this about? So this is a service that can do load balancing. The same way that we've discussed load balancing, it can do the same thing, but it adds additional capabilities.
All
So
right. So in terms of the OSI layer with the application and the normal load balancer, do they use the same? Are they on the same sort of layer?
that's a
So
very good question, Takofi, because the load balancer that we just looked at now can only load balance on layer 3 and layer 4. So as you saw, like we can only do things on, IP address and protocol.
yes, sir.
Like, oh, okay, anything coming from this IP address with that port goes to that IP address and that port. Simple, right? It does not have the intelligence to go, okay, maybe the HTTP header is different. It doesn't understand HTTP, right? All it's doing is this IP address and this port goes to that IP address and that port. So if I receive this, I send it over there. So that's all it's able to do. However, application gateway understands HTTP, HTTPS, because as you can see here, it has an HTTP, HTTPS listener. So it's actually just, load balancer capabilities with HTTP, HTTPS listener. And the advantage of that is that now we can do load balancer, or what is called application delivery, using information from the HTTP header because it understands HTTP. You say, what's the advantage of that, David? Right. So here's an example of an advantage of that. Now I can say, not only if anything comes in on this IP address and this port, send it to the IP address and that port. I can say, if anything comes in that is contoso.com, if it's /images, it's going over there. If it comes in and it's /video, it's going over here. So in other words, we can begin to use information in HTTP headers to make traffic delivery decisions. So that's what we're talking about. So, and you can see that we can even do things like multi-site routing, where we can say if anything comes in and it's contoso.com, it's going over there. If it comes in, but it's fabricam.com, you're going over there. If it comes in and it's another thing in the HTTP header, it's somewhere else. So that is what this is about. So that's application gateway. So again, it's very, very similar to what we're talking about. On the only difference is it understands that. But anyways, it has more difference than that, Sakofi. Here's another difference of application gateway. What you notice here, Sakofi, is that application gateway, like what you said, is referred to as a layer 7 load balancer because it has that HTTP listener, right? However, you notice that it can also have a web application firewall. So the advantage of that is it can not only do application delivery and traffic management, it can also do some security checks of this.
Got it.
Yeah. So let's go quickly create that. So if you want to create an application gateway, I won't go through the full details, just walk through the sketch with you. Like Sakofi said, there is a lab that's coming up. In the lab, Sakofi will talk to us about it. You're going to work with application gateway, load balancer. So make sure you do the labs and get proper hands-on on this. So we'll just, we have only 1 hour, so we can only do so much practical hands-on within 1 hour. So what I'm going to do is I'm going to go create a resource. And I'm going to go create an application gateway resource. So if I go to select application gateway resource. So by the way, I've not even checked to see if there's any questions at all.
Yeah, there's one question about the labs. So,
okay.
Oh yeah, I think there's another one. So I believe we will be. It's just anything that we can have, and we can have the slides.
Oh, the slideshow that I'm presenting.
Yeah.
It's like Mohammed, I understand why you want to want the slideshow and stuff. See, the guy that's paying the bill is Sakofi over there. You're talking to the wrong guy. You need to talk to Sakofi over there. He pays the bill. It brings in all the gold and all the money. So no, I'm only kidding. So we can probably share like the PDF, but it's a lot of like bespoke content. So we'll talk about sharing the PDF at some point. So there's a lot
All
of
right.
things that we need to take out here. So
All
we
right.
can
Let me
work
bring
on
up
that.
the next question. All
Okay.
right. So my question is: will application gateway add slash append X forwarder for headers for header?
Very, very good question. So it's a question that I currently do not have the answer to. And one of the reasons for that is because things change so quickly. So in the past, for example, application gateway didn't allow custom security rule configuration, but it allows it now. So let's see. Yeah, let's see if I can get the answer for you very quickly. It may well. So I think that. So what's the question against our coffee? Sorry.
Sure.
So it says with application gateway add or okay, will it add an X forwarded header if you want it to do so? And I believe the answer to that is yes, it can do so. So if you have a look at this, so this document, I'll put this document in the chat window for you, and this document answers your question. So, Vishal, what you can do is that if you can do like an insert. Oh, let's go back to the right one. So if I do an insert, so application gateway insert an forwarded header into all requests before it forwards it, right? So, and you can sort of specify the value here also before that's forwarded. So the answer to that, Vishal, is yes, it can do that. So good one. So as you can see, you can specify common header or you can even specify a custom header. So essentially you can do URL rewrite. You can rewrite URLs for this. So let me put this in the chat window for Rachel, and hopefully this answers your question. Okay, we have very little time. Let me quickly go share this one, and then we'll talk about Traffic Manager at the end. So, in terms of this one, so when I go to create it, let me quickly go to create it. So if I go to create application gateway, and when I go to create the gateway, let's see the options that I have. So I put it in my resource group. I'll call this DO application gateway 01. Now, the first thing about application gateway Sarkofi is that it has to be in a special subnet. And the subnet has to be called a particular name. So we'll talk about that in a minute. But let's look at the tiers first of all. So we have 4 tiers of application gateway. We have, standard, we have standard version 2, we have WAF, we have WAF version 2. What's the difference between these? So standard and WAF are sort of like the first generation of application gateway. So the main thing with them is they don't support auto scaling. So they only, so if I go to select, for example, standard, you see that I can specify the count of instances that I want. If I go to specify WAF, I'll specify this count of instances that I want. However, if I specify standard V2, I can have minimum or maximum. So I can do auto scaling. So that's the difference. So standard just does layer 7 load balancing without WAF. WAF option does layer 7 load balancing plus WAF, but it costs you more. So those are the 4 options that we have. So it depends on whether you want auto scaling, whether you just want layer 7 load balancing, whether you want auto scaling, layer 7 load balancing, and web application firewall. So that's what's going to determine the skill that you go for. For now, I'll just select WAF version 2, and I'll say minimum instance of 1 and maximum instance of 3. So let's move on. So what you see here is that if I put it in a network, the network has to have a specific subnet. And it's going to be looking for a subnet called application gateway. So it's complaining here. It's like, I don't have my subnet. I need a special subnet in your virtual network called application gateway subnet for me to be deployed into. So that's what it's complaining about. So to start with, I need to go first of all to my virtual network. And in my virtual network, I can go to create so if I go to that virtual network over there, I go to add a subnet. I'm going to call, and the subnet has to be empty also. So it cannot have anything else. So I'll call this app gateway subnet. App gateway subnet. And it should be empty. So I will leave it so it won't contain anything else but application gateway. So I'll go ahead and save that. So I have my app gateway subnet. So when I go back to create that, so I may need to go restart this whole thing so that it can detect my new subnet. And hopefully the use case for this is clear. So hopefully that's clear to us. So the use case for this. So let me quickly go to put that in there. So again, do app gateway 01, and I'll call that 1, and I'll put 3 to this. And I'll go ahead and select my network. And oh, it's still yet to. Oh, okay. I'm selecting UK South. That's why. Look at David. Come on, come on. We're in West Europe, not UK South. So let's go to West Europe. I was like, why does it still not discover that? So West Europe Virtual Network, and you can see that it's automatically identified that subnet. And it's like, yeah, I can use that subnet to deploy the workload. So here I can configure like my front end. Will it be private? Will it be public? So again, the thing that we talked about with standard. So I can just go add a new one, call this gateway IP, and go to my backend. So then I can go to hand essentially the same thing that we've talked about with standard load balancer. I can call this my web 2, and I can add, IP address virtual machine. In this case, I can add app services even. So I can go add app services. And actually, I think that's what I'll do. I'll go ahead and let me add virtual machines. It allows me to add my 2 virtual machines. So I have my virtual machine over there, and I'll add another virtual machine, my second virtual machine over here. So, okay. That's probably why that was failing, because this virtual machine seems to be unstable. Okay, let's remove this virtual machine. Let's go to add an app service. I have a few app services lying around somewhere, so I'll add the app service there. Okay. So you can see like some of this limitation is like, yeah, you can add virtual machine VMSs, you can mix them together in a backend pool, provided you configure it using PowerShell. But you can configure it using Portal. So you get some of these issues and stuff. So, okay, for now, I'm just going to use app services only. So I'm just going to add app services for that and app services for West Europe. So that will be good. And I'll just go
So
ahead and do
with a
that.
backend pool, can you have the resources in different regions?
With app gateway, yes, you can have them in different regions. Apologies, different regions, not different zones. So with different regions, so the way that it works here, Sakofi, is
Yeah.
that with the exception of that new capability that Microsoft added to load balancer, the global option that we saw,
Yeah.
if you want to do load balancing within availability zones in a region, you're either using load balancer or you're using application gateway. You're using standard load balancer or application gateway. If you want to do load balancing across regions, you're either using the traffic manager or Azure front door.
Got it.
So those are the options that you typically use. And again, if you go back to the architecture diagrams that we started with at the beginning, and you go have a look at this, you see that usually when you start talking about multiple regions over here, primary region,
Primary and
secondary
second.
region, you see that
Okay.
there's traffic
Manager.
manager. Why
All right.
this one is handling load balancing within that region, and this is handling load balancing within that region. This is handling the load balancing across the regions. And you see that across different architecture, right? You see that in this one also, right? You can see this traffic manager here, this application gateway handling this within the region, application gateway handling within the region, traffic manager across regions, right? Or this could be also be Azure front door is another example. So
All right.
Sakofi, because of the time, I'll just quickly run through one last thing. So
Sure.
hopefully that makes sense to people in regards to application gateway and load balancer. So one final thing is the traffic manager that we said can load balance traffic across region. What is this traffic manager about? So this is where we end. So let's go to the slides. Let's go to slides for application gateway routing. Let's go to the slide for traffic manager. So traffic manager, as we mentioned, is about across regions. But how does it work is the question. Traffic manager works using DNS Sakofi. So that's how it works. What do you mean by DNS, David? So we create our traffic manager resource and we link it up with our instances across multiple backends. So we do that. Now, the way that it works is our client goes to connects to Traffic Manager's DNS endpoint. Traffic Manager will look and select one of the instances, one of the backend instances to return to the client, and it's going to return the DNS of one of our instances to the client. And the client now goes to talk to that instance directly. In other words, Traffic Manager is not an inline load balancer.
So what are the criteria for you to give a specific region IP address?
Oh, we're going to look at those in a quick minute. There's about it's about six different ones. We're not going to cover all of them today. We're just going to cover like about two or three today. And I have some nice animations to make it clear. So, but this is the way that it sort of works is that, it's not inline. It's not as if this client is coming through Traffic Manager to talk to this instance. No, no, no. They're going to Traffic Manager to say, give me the address of an instance that you want me to talk to. Traffic Manager returns the DNS of that endpoint, and then your client goes to talk directly to that endpoint, not through Traffic Manager. The advantage of this is that Traffic Manager is not limited to just TCP or HTTP. It can essentially be anything, right? Because essentially it's just DNS based. It's just you come talk to me, I look at the endpoint, I go, here's a DNS for you to go talk to. So that's all it's doing. So the question that Sarkofi asked, which is always an intelligent questions from Sarkofi all the time. So we have different routing methods. So we have priority, we have the others. No, forget about all these slides. Let's go look at something more interesting, Sarkofi. Let's go look at the animation because I have some nice animation on how it works. So here are the different options that Traffic Manager has. So let's start with one of the routing method called priority. How does that work, Sarkofi? So in this use case, Sarkofi, I've got my instance in three regions: region A, region B, region C. That could be in Azure, that could be outside Azure, but in three different regions. I have a Traffic Manager profile, so that's what they're called. And I configure the Traffic Manager profile with my backend and the health check. So similar thing that we've been looking at. So we configure the backend and the health check. Now, when I configure this, if I selected the priority routing method, how does that work? What that means is that I have to give my instances a priority number. So for example, I can go region A, priority 1, region B, priority 2, region C, priority 3. And what Traffic Manager then does is that it uses the priority to say, I'm always going to send traffic to priority 1 except it failed. Always. So you can consider this to be an active passive scenario. In other words, traffic always goes to one endpoint except that endpoint has failed.
Right.
So in this case, everybody will be sent to region A because it's priority 1. So in this case, client comes DNS query to Traffic Manager. Traffic Manager is going to always return the DNS of region A, and then client goes to talk to region A. However, if something happens, Sarkofi, and region A fails, right? Then Traffic Manager will mark it as degraded. So the next time a client comes to request for an endpoint to connect to, Traffic Manager will always send region B because it's number 2 on the list. Except region B fails, then it's going to be marked as degraded, and then it will always return that. So essentially, this is an active passive scenario. The use case of this, what do you think, Sarkofi? What is the use case that you think this will be popular for?
I mean, it's probably just like on-prem, let's say, a firewall with active passive, whereby they they just want to ensure that there will be one specific region that is always handling the traffic. So when the main one goes down, which is their main sort of like server, probably a highly spec to handle most of the traffic. And then if they say it's out of the equation, then it will handle the traffic to probably something lesser whilst they look into fixing the other one. So that's how I see it. Yeah.
Exactly. And the scenario that is very popular for is for disaster recovery.
Yeah.
So in this case, I always want everyone to be sent to my UK South instance. However, if there were to be a disaster or something massive happens and the UK South is completely available, only then do I want people to be sent to West Europe. So this is not a high availability scenario. This is like a disaster recovery scenario of, oh, that's failed. Okay, plan B, right? So this is essentially plan B. That's what this is about. Unfortunately, we ran out of time, Sir Kofi. So what do we have for the people for the lab? So we'll pick up from there tomorrow when we start talking about Azure Storage. But before I talk about Azure Storage, I'll conclude Traffic Manager and then we'll talk about storage. But Sir Kofi, what do we have for the people today for the lab?
Yeah, sure. If you can bring up the slides.
Yep, let me go bring up the right slides very quickly. So let's go to normal slides. Come on. It's coming up. Here we go. It's coming up on my screen now. Oh, okay. That's strange. Oh, okay. It was just eating. Sorry. I was looking for it in a different
Okay.
place. Sorry.
All right, so Sir David have been talking a lot about traffic management. So we have prepared a lab for you guys to go through. So essentially, most of the service that Sir David have been talking about, load balancer, application, gateway, we have a lab that you can actually go through to accomplish this. So the first task you go through is preparing the lab environment. Essentially, is setting up three resource groups, and both all the three resource group will have different virtual networks, and then we will set up a peering. So if you go to two, it's actually configured in a hop and spoke, and we set up peering from VNet 1 to VNet 2 and VNet 1 to VNet 3. That will be in the labs that you can actually do yourself. So when we go to task 3, you test the transitivity of the virtual network peering. So essentially, you will have the ability to send the traffic, configure rules that will allow you to send the traffic across from VNet 2 through VNet 1 to 3, essentially. All right. So with the third one, we will configure the routing. So you attach a routing table to VNet 2 and also VNet 3, which will allow that sort of traffic to flow through VNet 1, a client on VNet 1 to then VNet 3 and vice versa. All right. So if you go to task 5, so for task 5 is implementing load balancer, just like say David demo to you. You have the opportunity to actually have a hands-on practice of this setup.
Yep.
Yep. And the last one is the Azure Application Gateway. So just like David did, just set up the Azure Application Gateway, and it's really something that I will encourage you to do, because listening to everything that we've talked about, it will always drive it home when you actually practice it yourself. So yeah, so that's what we have for you for this lab. The lab is being uploaded to YouTube now, so it should be ready within the next 5 minutes. Essentially, it's actually I'm going to publish it now, and then I'll give you the. Let me just publish it. Okay, I'm just going to. Okay, it's processing. So yeah, give it 5 minutes. It should be ready, and we will send you a link to. Let me just give you the link where you find the labs as well. So I'm just going to paste the link in the chat. So actually, it's just the same YouTube channel essentially. So once you go there, it should be there.
Awesome. Man, thanks very much for the amazing work that you put into this.
No
I really
worries.
appreciate that. But the only thing I'm getting confused is you want the Queen to come arrest me. I was never a sir. I never became a sir. I don't have the gold. I have no idea why you're calling me sir. People will get confused now. It's I'm just a normal layman. All your family.
You're right, sir. I mean, you are. I mean, we should give a hands of applause to David for the wonderful things he's doing with these Azure sessions, and I do believe everyone on this session is really appreciative of what you're doing. So you're definitely a sir.
I tell you, my goal is be like Sarkozy. The gold. Okay, thanks very much. Really appreciate it.
Thank you guys,
so much, everyone.
and I've posted a link in the chat so you can go through the labs as well.
Yeah. Have a
Okay.
lovely evening. So see you tomorrow,
See
which
you
will be our
tomorrow.
final session for this week.
Yeah.
Bye.
Bye.